Welcome back, guys. I hope you're all doing well. So the last time we stopped at this differential equation, right? The reason why is it's kind of new, and we haven't encountered yet so far. You guys anticipate, some of y'all might jump your chair and anticipate, oh, Justin is gonna you a complex number answer, and you are right and wrong, because our final answer does not contain complex, component. But the way we get there, we have to use the characteristic complex number. So we'll see what is that. Okay. So in order to solve equation 2, you assume that see you assume that d squared plus u squared can be factored as d minus a times d minus b. Okay. And then later we find I was right, and now we won't find b. But later we will. Okay, you understand what I mean by that? Okay, so 2, what does 2 become? 2 will become d minus a times d minus b y equals 0. Okay, you said this term, you said this equals z, so let d minus b y equals z. Okay, so what you got? You got d minus a z equals 0. Okay, apply the legendary formula. You have e to the power of ax d ax of z equals 0. Okay, so what you have? You have d divide e to the power of ax both sides. You got this equals 0, because 0 divided by e to the power of ax 0 apparently. So I'm going to rewrite this in normal form. X times z d to the power dx. Take the derivative with respect to x of e to the power negative ax times z equals 0. So integrate both sides. E to the power ax times z equals c1. Okay, times e to the power ax both sides. This is power e to the power ax times e to the power ax. You get z equals c1 e to the power ax. Okay, you got z already. Now let's solve for y. Okay, what's y? You have d minus b z y, right? Okay, so yeah, let me try this 3 from 3. Okay, so what you're gonna solve? Wait 1 second. Oh, I flipped the variable. It's not. Yeah, it's funny. This is the y and this is z. Okay, how do I solve this? Well, yeah, first I'm gonna, what's z? Z is c1 e to the power ax, right? Then I'm gonna apply the legendary formula. I love this so much. I love this, applying this legendary formula. Okay, divide by e to the power bx both sides. Okay, that's what you get. C1. Okay, what do you get? You get C1 times e to the power of ax minus bx. Alright, and then you write, and then I can write this as C1 a minus b x. Okay, just factor it. Now I'm gonna write normal form. Bx times y equal C1 a minus b x. Integrate both sides. All that, try to get more, right? Equal to C1. Then, oh, I forgot e here. That's funny. Yeah, I forgot e there. Imagine what it's like if you power someone to nothing. That would be so weird. E minus plus C2, right? Just basic derivative rules. Okay, now be careful, guys. Be careful. Now on this term right here, c1 over a minus b is a number, right? It's a real number. So I'm gonna replace it with c1 because both way c1 over a minus b and c1 point to a number, represent a number. I would pick a simple way. Of course, we just want simple life, man. So c1, okay, times e to the power of a minus bx plus c2. Okay, I'm gonna time both sides by e to the power bx, so you have y equal to c1 times e to the power of a minus bx e to the power bx plus c2 e to the power bx, right? So what is that? Y equal to c1, and this is, remember guys, this is ax minus bx. You times two power together, ax minus bx plus bx, it will become e to the power of ax plus c2 e to the power bx. Okay, this is our y for now, temporary. Now we're gonna find, remember how we say, you remember how we say d squared plus u squared equal d minus a, then d minus b. Turns out we can, because d squared plus u squared, you can write like this. You agree? And which I is complex numbers, which I square equal -1. Remember guys, differential equation deal with real and complex number. So you're gonna factor this, d squared minus ui squared go to d minus ui d plus ui. So now I would say, okay, a is ui, b is what is b? B is negative ui. So I say, in order for both of them to be equal, a will be iu, not a Korean band, but b is negative iu. Okay, yeah, it's complex number. So I'm gonna plug it into 4. Okay, so what is that? c1 e to the power of iux plus c2 to the power of e to the power of negative iux. Okay, now I'm gonna rearrange it a little bit. Y equal to c1 times e to the power of iux plus c2 times e to the power I to the power I times negative ux. Okay, this, some of y'all might stream your chair right now, be like, what is this, right? Some of y'all might might scream your head. Okay, I'm screaming too, but I just want to make sure. Okay, so what is this? So if you recall the Euler formula, which to a lot of people is the most beautiful equation in mathematics, because it's connect heaven and hell, or if you want to put another word, it connect like supernatural and the supernatural world and the mundane world. So it connect complex and real. Okay, so what do you say? Say e to the power ix will be equal to I sine x plus cos x. Okay, this is all the formula. Now I'm gonna replace it. So y equals c1 times I sine ux, okay, plus cos ux, okay, plus c2 times I sine negative ux plus cos negative ux. Okay, now change it a little bit. I sine ux, okay, plus c1. Wait, actually, yeah, I'm not gonna explain it. I'm gonna keep it first, and then later I will explain it. I will expand it. Cos ux. Okay. In mathematics, if you don't know what to do, just keep rewriting the function. So what is this? If we saw I'm gonna put, remember guys, don't forget, sine of negative x equal to negative sine x, cos negative x equal to cos x. Don't forget it, okay? So it would be, in this case, it would be negative I sine ux plus cos ux. Okay, now I'm gonna expand it. So it would be c1 I times sine ux plus c1 times cos ux plus c2 times negative I times sine ux plus c2 cos ux. Okay, what does it equal to? Y equal to I'm gonna group sine ux together. What is it equal to? Sine 1 c1 times I minus c2 times I plus cos ux times c1 plus c2. Okay, and remember guys, c1 c2 are complex number, and remember, complex number can be real number, because if you write complex number like this, it will be real number. 5 plus 0i. Okay, it will be 5. So the complex part, the imaginary part is gone. So remember, the complex number consists of the real part and the imaginary part. But yeah, you see the point. So c1i minus c2y refer to a complex number, right? So I'm just gonna, replace it with c1, because like, the on day, I don't want a complicated expression to denote it. I just want to be simple. Similarly, c1 plus c2 I will replace with c2. It both refer to a complex number. Okay, so guys, this is our this is our answer. This is our answer for this case. Where's that? Y double prime plus u square y equals 0. Some people write like this. Some people write like a cos ux plus b sine ux. Okay, it's the same way. Okay, you just change the letters. It's all the same because it represents a complex number. So okay, so what we learn is y equal a cos ux plus b sine ux is a equation. It's a solution to a family solution. Why is family? Because a and b can be anything. Together, all of them combine and form a family. It's kind of romantic, beautiful, right? So in the end, this a cos ux plus b times sine ux is the solution to y double prime plus u square y equals 0, and we just show it using operator. Okay, thank you for your attention. In the next video, I will explore the last one of the very last final important characteristic of operator, and I think it's good for our intro series. Thank you.